Hello there and welcome to another Python tutorial. In this tutorial I want to answer a question that was emailed in regarding writing Python code to do binomial coefficients. So I'm just going to start with a short note reminding you what the binomial coefficients are. So I've started by typing a pair of triple quotes into Python. That lets you write whole paragraphs of text instead of just short comments. So I'm going to just remind us what it is we're trying to do. So remember that the binomial coefficients are expressions which are written using the following notation. So we write them as a pair, more often as a vertical vector, nk, and we call these n choose k. Now n choose k takes the value n factorial divided by k factorial times n minus k factorial. So one method for computing binomial coefficients is to use a factorial function. So let's try that here. First I'm going to write down the standard template that we begin every Python program with, which is an empty main function and a line at the bottom which tells the computer to run the main function if we're running this file rather than importing it into another file. So the first thing we need now is a factorial function. So let's write the factorial function. There are many different ways to do this. I'm going to quickly show you two different ways. Now the factorial is defined to be the product of the numbers from 1 up to n inclusive. And one way of building up a product is to start with the number 1 and then repeatedly multiply up by extra numbers. So in this case I'm going to start the product, I'm going to call it prod, and I'm going to start that as 1, and then I'm going to visit all of the values k from, now if you look at what the interface is doing, it's actually trying to help us out here by reminding us that a range can have an optional start, a stopping point and a step. So in this case we're only going to use the start and the stopping point for this range. So we already have the number 1, we want the numbers 2 up to n inclusive. So we need a range that begins with 2 and that ends with n. Now ranges end one step before the stopping point that's listed. So we need n plus 1 there. And what we're going to do then is take our product so far and multiply it by the number k. And then we can return the result. So let's just test this code out in the main function. It's always a good idea to test out our programs. Let's see if we can successfully compute factorial for some simple values. Okay, so I'm going to run this function now, and on the right hand side we see 1, 1, 2 and 6, and if you check from the definition of factorial you'll find that those are the correct values. That's one way to write the factorial function. If we wanted to do a more thorough check, of course, we could test a whole range of numbers. So let's begin with 0 and end with the number 10, and let's calculate factorial of j in each case. Okay, so that method for calculating factorial used a loop. So we used a for loop which made the index k go from 2 up to n inclusive. A different way to calculate factorial would be to do it recursively, which is where we write a function which uses itself. So let me just quickly demonstrate that method. So I'm going to call this one factorial 2 since we've already used the name factorial before. So with this method we first check whether we have the simplest case for a factorial, which is the factorial of 0, which is defined to be 1. So we test if n is 0 and we immediately give the answer 1. Now remember what the return statement does. The first point at which Python meets a return statement, it quits the function that it's currently executing and returns back with the answer. So if n is 0, this return 1 line will actually exit this function, which means that if we ever reach the next line here, then n can't have been 0. So in the case where factorial isn't 0, for example where we had the factorial of 3, we could use a recursive definition of factorial. So the recursive definition of n factorial is that it's n multiplied by the factorial of n minus 1. So our factorial 2 function here uses itself. So let's just test that it produces the same results as our original factorial function. And you can see that in every single case we have the same result from both of the functions. Okay, so now that we have a working factorial function, we can build a binomial coefficient function simply by implementing this expression here, n factorial divided by k factorial times n minus k factorial. So let's do that now. For now I'm going to remove the recursive factorial function. And I'm going to implement the binomial using just this iterative version. So I'm going to define a function called binomial. Now we need both n and k in order to calculate it, so they must both be listed as inputs. And we can simply calculate the value of the expression n factorial divided by, and now we have to be careful here, we need some brackets so that things are done in the right order. We need to calculate k factorial times n minus k factorial before this division is done. So we need brackets around the denominator of this fraction, and it's a good idea to write a matching close bracket every time you write an opening bracket, and then put the cursor back inside. So in the denominator of the fraction we need factorial k times factorial n minus k. So now we need to test out our binomial function, and we have both n and k to play with as inputs. So back in the main function, let me test it first for some simple values. So let's see if we can find binomial 1 and 1. Let's also do binomial 2 and 1. And let's see whether this works. We get 1 and 2. If you test against the definition of binomial, you'll find that they're the correct answers. Now, a more thorough check would be to write a loop to test many values here. So let's allow our n to range. Now we have to think of a good starting point and stopping point here. Binomial coefficients only really make sense where the factorial is defined, which means n has got to be at least 0. So let's begin with a range 0 and count up to perhaps 3. Now for each value of n, the valid values of k, well again the factorial needs an input which is at least 0, and since we have both a k here and an n minus k, they both need to be at least 0, which means that k itself must lie between 0 and n inclusive. So we can use the range 0 n plus 1 to achieve that. Now before we do any binomial calculations, let's just check that the correct n and k values are being produced. So I'm just going to print n and k each time around the loop and see what we get on the screen. Okay, so let's focus for example on the case where n was 3, then k ranges from 0 through 3 inclusive. So it looks as if we've done the correct thing there. Now in addition to n and k, let's print the value of the binomial coefficient that our function is calculating. And then I'm going to run the code again. Okay, so is this the correct answer? Well, let's explore a bit further what the binomial coefficients are. So I'm going to add an extra comment above. Now the binomial coefficients form a special structure that's often called Pascal's triangle. And Pascal's triangle has the following form. On each row the numbers are formed by adding up the two numbers above. So I've indicated the first few rows of the triangle. I'm just going to space it out in a more conventional way now. Let's notice some things about this. The entire left hand side of the triangle consists of the value 1. So does the right hand side. And provided we're in the interior of the triangle, for example this point here, then each number is the sum of the two numbers directly above. So 1 plus 2 there gives 3. How does this relate to the binomial coefficients definition? Each row in the triangle corresponds to a value for n. So the top row is n equals 0, the next row corresponds to n equals 1, and so on. Now the position within each row is determined by the number k. So the left hand side in each case is k equals 0, the next number along is k equals 1, and k ranges all the way up to n. So this special structure gives us a clue of how to recursively calculate the binomial coefficients. So I'm going to replace the binomial code that I've written here by one that calculates them recursively. I'm going to also remove the factorial code, which we no longer need. Okay, so let's think of the simplest cases first. So the left hand side of Pascal's triangle corresponds to the case where k is equal to 0. Remember, k gives the position within each row. So if k is 0, the value of the binomial coefficient should simply be 1. Now, remember that return quits the function and returns with the value given as the answer. So if we ever reach this next line, it means that k wasn't 0, and we can test for other possibilities. In particular here, let's test to see if we're on the right hand side of Pascal's triangle. Now, given a value for n, the values of k run from 0 up to n, so the right hand side of Pascal's triangle corresponds to k equal to n. So if k equals n, we know we're on the right hand side, and once again we can return the number 1. So I'll just tidy up this code. So if k is 0, we return 1. Otherwise, if k is n, we return 1. Otherwise, we know that we're in the interior of the triangle, at a point, for example, like this one, in which case the value for the binomial coefficient n choose k should be the sum of the two values on the previous row. Well, if we're presently on row n, then the previous row must be row n minus 1. And the two values must be k minus 1 and k. So, provided that we haven't already returned from the function, then we already know that k isn't 0 and k isn't n, so we can safely return as our answer the binomial evaluated on the row above in the position 1 to the left, plus the binomial on the row above in the same position. So that gives us a recursive binomial coefficient function. And again, I'm going to run this code and we can check whether we see the correct structure of this triangle. And you can see, if you follow through carefully, that we've produced exactly the same result as we had before using the factorial function. So this is now a recursive binomial coefficient calculator. Let's just tidy this up a bit. Notice that we return 1 in the case where k equals 0, but also in the case where k is n. So we could combine these two cases together by saying that if k equals 0 or k equals n, then we return 1. So that means we only need a single if there. And again, let's run the code to make sure we didn't break anything. So the same results are produced. Now the next thing we should do is to be rather careful, because if a negative value was put in for n or k, then this code may run forever. For example, if we use the code binomial with -1 for n, then that will result in a call, a function call, to binomial -2 in this position, which will then result in turn in a binomial -3, and so on. It's a good idea when you've written a function to check whether the inputs make sense before any calculation is done. So at the beginning of the binomial code, we should demand which we can do by asserting we should demand that n isn't a negative number, because if n is a negative number the calculation wouldn't make sense. So demanding things in Python is done by making an assertion. We assert that n has got to be at least 0, and we can also give some text to be printed in the case where that's not true. So if Python comes to this line and finds that n isn't greater than or equal to 0, it will quit the program and print out the text. So a suitable error message is to print to the user that the binomial nk is not defined if n is negative. So let's just test that that works. If I go in the main function and deliberately try to calculate a bad binomial, let's try binomial minus 3, 4, and let's run this code and see what happens. So we get an error message. So we have assertion error, binomial is undefined for n less than 0. So if someone was attempting to use our binomial function and they accidentally gave it a negative input, this would help them to track down the error that they'd made. Notice also that this demonstrates to us exactly where in our program the binomial function was used. Now the second thing that we want to check is that the value for k makes sense. Now remember that k is meant to go from 0 up to n inclusive. So let's demand that. Let's demand that k is at least 0 and that k is at most n. And let's print an error message in the case where that's not true. So I've printed on the screen that the binomial is undefined for values of k less than 0 or values of k bigger than n. And again, let's give this a bad case. So let's try 3 and 4. So you see here that we see the error message coming up, which again would help someone to find an error in their program if they were using our binomial coefficient. That's the end of this tutorial. Thanks very much for listening and enjoy Python.